Hello math students, welcome to your first video math lesson. Today's lesson is on function notation. Woo! Please have your notebook out and be prepared to take beautiful organized notes today. To try and help in your organization, I color-coded the slides to help signify when the warm-up was, when you had formal definitions, and then the slide for examples. Alright, let's go. Before we get into the lesson, I want to start with a warm-up just to get your brains moving, get you in the math mode. So I'm going to ask, whenever we have a warm-up, that you pause the video and you try the warm-up on your own for about 5 minutes. I don't want you to get super stressed out over the warm-up or upset because you're not sure what the answer is. Give yourself time, just about 5 minutes, and then after that you can resume the video. We'll keep going. I'll give you my solutions to the warm-up, and then we can head over to the rest of the lesson. So at this point, go ahead. I'll explain the warm-up first. In this warm-up, I see that there's a Venn diagram with y equals 2x plus 3 on the left, and then f of x equals 2x plus 1 on the right. So with a Venn diagram, you should find the differences and the similarities between those two things. And you can find at least 2 things that are different and 2 things that are the same. Okay? So your goal is to find the differences and similarities between those 2 equations. So pause now. Welcome back. So I know it may have been a little tricky to figure out what some of the similarities and differences are. Here's what I got. So I think the most obvious thing is that they have different y-intercepts. So the left equation has a y-intercept of 3 and the right equation has a y-intercept of 1. Another difference is that one is in function notation, its function name is f, and the other one is just kind of a generic y equals mx plus b equation. Some similarities: they both have a slope of 2. They're both linear functions, so they both have a graph that is a line. They both use the variable x. You know that they could have used any variable that they wanted, but they both used x. And they both have the same domain and range. The domain and range are all real numbers. So at the bottom there's a question asking you which of the 2 ways of writing equations do you prefer. You might be more used to what's on the left with the y equals mx plus b. It's a little bit more familiar, but I know that you've learned this on the right. On the right is the function notation, where they name the function f. And what is over here is what we're going to be focusing on this for this learning target, and this is the notation that I would like you to use for the rest of the year. Okay, so here's the formal definition of function notation. You can see in this box. Function notation has 3 parts basically. So it has the name of the function, which in this case is just function f. So here's my name of the function. Then it has what's inside the parentheses. So what's inside the parentheses is the input of the function. And another vocabulary word that we're going to actually use for input is argument. So another word for the input, or what's in the parentheses, is called argument. And then on the other side of the equal sign is whatever the function rule is. So that's the function rule. In this case, the function rule is to take the input, multiply it by 2, and subtract 3. That would be the function rule here. So those are the 3 parts of function notation. Function notation is really nice because just instead of x, you can change it to whatever input you want. And that just makes directions way more easy and straightforward. And then at the bottom, we have the different operations that we can perform on functions. So we can add, subtract, multiply, and divide functions. Oops. It's not getting, there we go. We can add, subtract, multiply, and divide functions. And so I'll just show you the quick examples of those 4 different operations. So you can see in the examples over here, we have the function f of x and the function g of x. Okay. So if I were to add them, it's very straightforward, just 5x, I'm adding f of x, and then g of x is plus x plus 2. So we can see, sometimes parentheses makes it easier to see what is happening. There are my 2 functions, and then you just combine like terms to be 6x plus 2. Subtraction. Subtraction, it actually, whenever you see subtraction, I would always recommend using parentheses. And it is required to use parentheses for whatever is after the subtraction sign. So whatever you are subtracting, you should always put parentheses around it to help remind you that the subtraction needs to be distributed to everything. So this subtraction is distributed to the x as well as to the 2. So it's 5x minus x, which is 4x, and then the 2 becomes subtracted. Multiplication, this is another instance where we need parentheses. Okay? So that is the proper way of writing this, 5x times x plus 2. If you didn't use parentheses, I'll just put this out on the side in red to indicate that it's wrong. If we didn't use parentheses, we would have 5x times x plus 2. And if you write it that way, you only need to multiply 5x times x, and we'd get 5x squared plus 2. And this is wrong. That's not right. If you have parentheses and do it the correct way, you distribute the 5x to everything. So we get 5x squared plus 2x. Okay, and then division. Not really anything we could simplify here. One common mistake is students, oopsie daisies, students really like to try to cancel out like that. Oops. Students really like to try to cancel those out, but it's just not allowed. The only way we could do that is if we are able to factor out the x. So we can't just cancel it out because there is no x right there. So we can't factor an x out. So that move is not allowed, and that is the most simplified form that we have for that function. Okay, so just some review of basic function operations, and we'll do some more challenging examples on this page. So we have 2 new functions. We have g and we have h. So g of x equals negative 3x plus 2, and h of x is 4 plus 7x. And we have all of these cool operations we're going to do. So the first one is just g of 4, and so that means that the value of the input that I'm using is 4. So instead of x, I will write 4. Like that. So this equals negative 12 plus 2, which is negative 10. There's my answer here. And so what this means is that the value for negative 10, this basically gives me a coordinate point. So for negative 10 is a point on the graph of g. So g, if I were to graph it out, the point for negative 10 would be on the graph of g. Okay. Next in b, we're multiplying. So if I were to multiply, I could write it like this. And I want you to look at that and figure out what I did wrong, because I wrote that totally wrong. So take a second, figure out what does Miss Patterson need to add. And if you said parentheses, you are totally right. So parentheses are really important. That means that everything needs to be multiplied together. So first I'll multiply negative 3x times 4. That's negative 12x. Then negative 3x times 7x. That's negative 21x squared. Then we have 2 times 4, which is 8. And then 2 times 7x, which is 14x. So combining like terms, I get negative 21x squared plus 2x plus 8. That is not a factorable function, I don't think, so we'll leave it like that. Okay. Ooh, C. I kind of threw it through. C is a little tricky. I wanted it to be tricky, but we'll see if it actually works. So this 3 is just a constant. I'm just going to keep it there being multiplied in the front. And now I can see that my input into G is x plus 1. So this whole thing is my input. So it's very similar to when I had the input of 4, and so I just replaced x with 4. But now my input is x plus 1. So wherever I saw x before, I want to replace the x with x plus 1. So that'll look like this. Negative 3 times x plus 1 plus 2. And I'll make sure to put that whole thing in parentheses because it needs to all be multiplied by the 3 right there. So I'm going to simplify inside the parentheses first by distributing that negative 3. I can still simplify in there a little bit. Negative 3 plus 2 is negative 1. And then finally I'll distribute the 3 to get negative 9x minus 3. Like that. Cool. I want you to actually try D on your own. So I'm going to be solving it silently. And if you feel like you've got it, try this on your own. So you should be looking down at your paper instead of up at the video. So go ahead, look down at the video, try D on your own, and then once you're done, you can check up with me. I do want to note that it uses the function h and g. Did you get negative 20? Great job. Or, if you didn't, go ahead and pause me and figure out what your mistake is. So figure out what your mistake and make it so that you do get negative 20. Okay. So these last two are definitely a little bit of challenges. I'm going to highlight them in red. They're a little bit more challenging because they're a little different. So I give you full directions in part E. It says, I want you to find x when g of x equals negative 4. So I'm not telling you what the value of x is. I want you to figure out what x is. But I do tell you that g of x equals negative 4. So what I'm going to do is I'm going to replace g of x with negative 4 and then set it equal to my equation. So instead of g of x, I have negative 4. And it's equal to negative 3x plus 2. And now in order to find x, I just solve this equation. So to solve the equation, I will start off, oh, it's too small. I'll start off by subtracting 2. On both sides. And then I will divide by negative 3 on both sides. So what you do to one side of the equation, you have to do to the other. So negative 6 divided by negative 3 is positive 2. okay? So in this one, I gave you more explicit directions. I said find x when g of x equals -4. This, I did not give you all those same directions, but it's asking the same thing. This is just using straight up function notation. So it says h of x equals -5. That is telling you, okay, set -5 equal to the value of h of x, which is 4 plus 7x. Okay, I'll put lines so whoosh, it doesn't look so nuts. Okay, so that means I'm replacing h of x with -5. So I'm just gonna solve for x again. I'll subtract 4 from both sides. And then to get x by itself, divide by 7. So -9 over 7 equals x. And that's my final answer. Okay. I hope that this was a pretty easy review of function notation, how to use function notation to substitute values in for x, as well as how to substitute values in for the function, like we did in parts E and F.